right, y'all. This is our last presentation of the day. This is a group mentored by Dr. John McCarthy. Let's give them our attention.
All right. Hello, everyone. The following presentation is about mine and my colleagues' 2024 summer research project, funded entirely by South Carolina EPSCoR. Our agenda today consists of a brief introduction of the research team, followed by background information regarding a general energy system, then the more specified upstate energy system. This brief internship crash course will be directly followed by the data that we managed to collect and the relevant SysML model associated with said element. Once this is all said and done, we will take any and all questions from the crowd, assuming we have time for it, which I think we do. Now, on to the fun stuff. My name is Whitaker Theo. I was the model master for this research internship. I was also in charge of researching the generation elements of the electrical energy system.
My name is Bobby Timmerman, and I was in charge of the electrical transmission and distribution data.
And joining us in spirit is Mr. Juan Salas Gonzalez, who is not here today. He was in charge of researching the electrical storage, use, and environment. And then we have our faculty advisor, the lovely Dr. McCarthy from the physics department. The purpose of this model is to provide a framework for teaching people about the South Carolina electrical energy system. We also hope to use this model to provide policy decision makers with the important information that they need in order to better regulate the energy industry and to provide a tool that students could use to explore what-if scenarios. What happens if we replace this coal plant with this nuclear plant? Or what happens, God forbid, a hurricane comes through and knocks down almost our entire power grid? But most importantly, we want this model to be used as a tool to learn. Now it is time to learn in roughly 3 minutes what took us 2 months to learn and sort through. Here we have a map of North Carolina and South Carolina counties. I know what you're thinking. If you sat down and told me that Charlotte was in upstate South Carolina, I would be giving you weird looks as well. But for our research purposes, we had to extend what we considered to be the upstate into regions that were primarily operated by Duke Carolinas that happen to be major contributors of South Carolina's electrical system. I will give everyone a second to look at all of the wonderful counties that are included in our little Franken upstate. Now, a brief rundown of a generic electrical energy system. We start at, let me see if I can do this. We start at a generation facility. So think nuclear, coal, wind power, which then produces electricity to either be immediately stored or sent through transmission lines to transformers that basically turn the electricity from explodey levels to non-explodey levels. That's safe for human consumption. We have been, throughout the presentation, I would like to clarify that we primarily focused on the electrical energy grid that was operated by Duke Carolinas. But in reality, there are 33 different registered electric companies in our Franken upstate. As for generation elements, the upstate currently has 3 nuclear, 7 natural gas, 10 hydroelectric, and 3 solar plants. For storage, we only have 2 hydroelectric. For transmission lines, we have 5 500 kilovolt, 32 200 kilovolt, and 202 100 kilovolt transmission lines. For substations, we have 10 500 kilovolt, 64 200 kilovolt, and 404 100 kilovolt. And now, without further ado, and very strained eyes, our SysML model. It's a little hard to see, hence the strained eyes, but this is an interface block diagram of the upstate electrical energy system. This zoomed in portion of it shows us a handful of transmission lines connected to substations. And now, to talk more specifically about energy generation, me. In researching the energy generation elements, the key parameters that I looked for were the facility name, type, location, the transmission line connected to the plant, the owning utility, so Duke, Dominion, etc., the peak capacity, the capacity factor, the annual output, cold startup time, operational life, annual CO2 emissions, area, and levelized cost of electricity. Some secondary parameters that I looked for were the production parameters, the pollutants, the cost parameters, and the RAM parameters. Here we have a photo of the very beautiful Oconee nuclear plant next to an arguably less pretty block definition diagram. The large block on top represents all of the individual plant's attributes as a whole. Now, via proxy, we have electrical storage units.
Yeah, so I'm not one, but I'm going to stand in for one today, and we're going to talk about electrical storage element. So there are about 5 different types of storage in upstate, or at least types of storage that are mostly used. Hydroelectric pump storage, lithium battery, molten salt compressed air, and there are also others. But in the upstate, we only have 2 hydroelectric pump storage. The primary storage element parameters, the bolded ones are the ones that are most important. The facility name, type, location, and then the maximum storage capacity and the maximum power generation. So here we have a picture of the Bad Creek Pump Storage Facility. And to the right you can see that we have a individual block from a block definition diagram of Bad Creek Storage Facility. As you can see, it has each of those primary parameters and also has the individual values for those as well. Now we're going to talk about mine. So this is the electrical transmission element. So our primary parameters for the transmission lines were the identifier, the location, the starting substation, the ending substation. All of the transmission lines that I researched were owned by Duke Energy. The voltage, power, the installation date, we were given about 50 years of expected life for them, and the construction cost is around $1 million a mile. And then we have the operation and maintenance cost. Here we have a picture of a transmission line, and then we also have a picture of the block definition diagram. Again, not as pretty as the master. But it's the same rule follows. The bigger block represents all those primary parameters, and then they represent all of the transmission lines, which are they're divided up into groups based on the voltage, 500 and 200 and 100. Now we have the distribution element. Again, we have the substation parameters, the identifier, the location, the owner, associated generation/storage facility, the voltage, installation date, and we got about the same expected lifetime of about 50 years. Here we have a picture of a substation, and then we have a picture of a block definition diagram. Same rules follow. Large block represents all the smaller blocks. And the substations are also divided based on voltage as well. And here we also have representation of distribution lines and distribution boxes. We didn't map or graph these because there are just so many. It would be impossible. I spent about a month just doing the ones that we have already, but we also wanted to show representation that they are there. So now the ESS actors and environment. Again, I'm not one, but for today, I guess I can be for like a few minutes. So our system has 2 types of actors: users and maintenance crews. The environment is composed of the power companies, fuel providers, construction companies, and the physical environment. And these are the parameters of physical environments like temperature, soil rate, sorry, I can't read, and overcast/rainy days, wind speed, and wind direction. So here are actors and environment block definition diagrams. On the left, you can see the actor block definition diagram is composed of the actors we mentioned previously. On the right, we can see the environment, which is composed of, again, the power company, fuel providers, construction companies, and physical environment. So here we have South Carolina users. The commercial and industrial combined use more energy than residential. However, there are far fewer industrial and commercial customers, and they pay for lower rates. And then for our utilities customers and counties, on the left we find a much further itemized table that gives us data on the upstate's customers and their use by company and county. On the right we find the energy use by specifically county. Any questions?
Questions for our final group here?
Okay, I think I have one. We saw after the hurricane, there's some transmission lines that are buried versus ones that are above ground. Did you include the buried lines? Does the burying of the lines just cost more? Is it like buried lines versus hanging transmission lines? Is there a difference?
Well, the thing is, those lines, like specifically the ones that are coming from your homes, those are distribution lines. And unfortunately, there are so many in the upstate, that it would be impossible for us to graph those. So all of our transmission lines that we have are all overhead.
Okay.
Because we only got down to 100 kilovolt after that. I mean, I'm at, I think, like 404,
Mm-hmm.
404 distribution lines, but like 200 and 200 kilovolt lines. And that's just looking at the upstate. So unfortunately, we didn't get data on the underground, but yeah.
Some of the data that you're collecting on your own, but couldn't you contact like Duke Power or Broad and have them provide you with, because I'm sure that they have an inventory of every single line.
Yes, we were actually in contact with both the Office of Regulatory Staff. We were in contact with Clemson, and we were also in contact with Duke Power to get more information on the lesser available stuff.
I did ask, do you guys just hey, you guys have a master list of transmission lines, but unfortunately they aren't able to disclose that. That's a risk to the country, and they're
State
national
security.
John.
When we were talking to people before Duke Energy, they were we were talking to people
You're gonna
before Duke
get Walker put on
Energy,
FBI
and they
list.
were like, you might have to sign an NDA. And I was like, oh my gosh, but he actually, we were able to find one or two websites that actually do a really good job of marking that out. ArcGIS was really, it's ArcGIS now.
So you shouldn't tell me that stuff, now you see me.
Dr. McCarthy, yes.
I'd just like to point out that Duke and the Regulatory Office and actually we also had Conservation Voters of South Carolina as consultants on this. And all of them, and especially Duke, were very helpful in pointing us to publicly available information that we could use.
That's good.
Yes, I will say ArcGIS is publicly available.
Okay.
Yeah, didn't pull that off the dark web anywhere.